We were here on page 3 last time, and I had asked you guys to finish up page 3, right? Let's do it now. Find the total amount of interest paid over the life of the loan. So there's a formula for interest paid. I'm on part D. Interest, oops. Over the life of the loan is the total paid. What's with all these pens today? Total paid minus the total principal paid. So what's going on in this problem? There are 5 payments of Q. So 5 times Q, where Q is 1186.98 minus the total principal paid. So how should I find the total principal paid? Do I have to do all that? The whole loan is only 5 years. Yeah, minus the loan. So how much is the loan? 5,000. Follow? So when I clean this up, I get 5934.90 minus 5,000, which is 934.90. So this total principal paid is the whole loan itself. Creating the amortization schedule. Time, payment, interest, principal, and outstanding loan balance. So at time 0, you start with a loan of $5,000. We saw in part A that each payment was 1186.98. So let's put that in. Time 1, time 2, time 3, time 4, time 5, 1186.98 throughout. So starting at the beginning, at time 0, I have 5,000. What's the interest rate? 6%. So 5,000 times 6%, $300. The total payment is 1186. Subtract the interest like this. Thank you. Equals the principal. So 886.98. The outstanding loan balance at 1 will be 5,000 minus 886.98, leaving me 4113.02 that I still owe. Does that make sense? If it doesn't make sense, tell me now, right? Because it's the same step for every time. So I found the interest by saying 5,000 times 0.06. And then amortization is such that the interest has to get paid first. So whatever the payment is, you first have to subtract the interest from that payment, and the rest is your principal. And then the outstanding loan balance keeps decreasing by the principal paid amount. Got it? Keep doing this for each one. So here the next interest would be 4113.02 times 0.06, which will give you 246.78. This minus that equals 940.20. Notice how the principal paid is a little bit more than it was the year before. How much more is it? Yeah, it's a factor of 1 plus I. This 1 plus I business will only work if all your payments are constant. Right? Yes? Yeah, that's what this thing means. That means the same thing going down. Right? So I want to make this point very clear, because when your payments start increasing by a fixed amount or increasing by some growth amount, this formula of 1 plus I being the factor goes out the window. Okay? So 4113.02 minus 940 gives me 3172.82. Keep going. This times 6%, what do you get? 3172.82 times 6%. What do you get? 190.37. 1186.98 minus the interest will give you the principal paid, 996.61. Again, notice it's a factor of 1 plus I. So the outstanding balance is this minus that, 2176.21. Again, interest, 6% of that gives me 130.57. Payment minus interest equals principal, 1056.41. Again, it's a factor of 1 plus I. This minus that will give me the outstanding loan balance. Now I'm in the last year. I have to pay off the loan. Find the interest. It turns out to be 67.19. Payment minus interest, 1119.79. These are supposed to be the same, so I'm just off by a penny. Right? So the principal paid has to be the outstanding loan balance in the last year, because you want to pay off the loan. So OLB, 0. What's your question regarding this? Nothing? Next page. Next page, I want to do this, and then I want to do 5.2.2. So some of the stuff you already know. It says that the interest in the teeth year is equal to I times OLB T minus 1. We already know this, right? Didn't we do that in our amortization schedule? Let me just bring it back up. Look at this. Didn't we say that the interest in the 5th year was equal to the OLB of the 4th year times the interest rate of 0.06? That's all this is saying. So it's saying whatever you owe at the end of the previous year, multiply that by the interest rate to get the amount of interest that you owe the subsequent year. We know this already. Do you have any issues with this? Okay. So the other thing you should know is I in the teeth year is equal to Q minus Q V to the n plus 1 minus T power, where this is the principal paid. This should be memorized, right? Remember we said that the exponent of the principal paid is always n plus 1 minus T? So I'm just pulling this out of that, right? That the principal paid would be Q times V to the n plus 1 minus T. And because the principal and the interest always add up to the total payment, I'm subtracting from the payment the amount of the principal to come up with the interest. So these are equal. Let's put it here. Is equal to I times OLB T minus 1, which is otherwise written as Q A angle N minus T minus 1. Right, so I'm standing at time T minus 1. There are supposed to be n payments. So I have n minus t minus 1 left. So I'm taking the present value of the t minus 1 payments that are left to find OLB t minus 1. Right? So present value of remaining payments. Remaining payments. Okay, here it's saying that the principal payment is equal to the total payment minus the interest. It should be noted that P at t plus s is equal to P of t times 1 plus I to the what power? S power. So this is saying the principal in the fourth year is equal to the principal in the first year times 1 plus I to the fourth power. Follow me? So if I were to show you this on my amortization, I'm saying that the principal somewhere down here is equal to the principal up here times 1 plus I to the second, 1 plus I to the third, 1 plus I to the fourth. So my S is 4. Follow me? Okay. And this is saying that the balance in the teeth year is equal to the previous OLB. You know that B and OLB are the same, right? So B is equal to OLB. So it's saying take the OLB in the previous year, subtract the principal payment that you just made, and that's your new OLB. But you know that from doing the amortization schedule, right? Okay. Let's do this example. An amortized loan of $100,000 payable over 25 years at 6% is to be repaid by annual payments at the end of each year. Okay. I annual 6%. Loan is $100,000. Let's draw a timeline. 100,000, 25 years, 6%. Payable annually? Yep. 1, 2, so forth. Find each of the 25 level payments. So we use the present value equation, right? 100,000 is equal to Q, A angle 25 at 0.06, which is equal to Q, 1 minus V to the 25 over 0.06. Therefore, Q turns out to be 100,000 divided by A angle 25.06. Plug it in your calculator, you get 7822.67. Each payment. So let's put that up here. 7822.67. That's every single payment. What is the loan balance at t equals 0? Well, yeah, at t equals 0, nothing's been paid. So the loan is the loan balance at 0, which is 100,000. What is the amount of interest in the first payment? And what is the principal repaid in the first payment? So I1 is equal to lowercase I times OLB0 equals 0.06 times 100,000 equals 6,000. P1 is equal to Q minus I1, which is 7822.67 minus 6,000, leaving me 1822.67 as the principal payment. Look how interesting this is. What percent of the payment was interest for the first payment? Let me just see if they asked you that on the next page. They didn't. So, oh yeah, here it is. What is the principal repaid in the first payment? But they didn't say what percent of the payment constitutes interest. Remember we were saying last time that most of the payment is going to be interest in the beginning, and you're wasting your money in the beginning because you're just paying off the interest, paying off the interest. What percent of the payment constitutes interest? Look at this. $6,000 of the first payment was interest. So 6,000 divided by the whole payment, 7822.67, is equal to 77% of the payment is interest. So when you refinance, right, you have to think about that. That in the beginning of the loan, most of your payment is just going to be interest, so it's wasted. It doesn't go towards your principal. So you have to weigh that against a lower interest rate that you might have when you refinance. Follow what I'm saying? Next one. Calculate the principal and interest in the fourth payment. How should I do this? Okay, one way to do this problem is to take I in the fourth payment equals lowercase I times OLB3. And then how will I find OLB3? How should I find OLB3? Yes? Pardon me? Oh no, you don't want to draw the whole table. You don't want, you could, but you don't want to do that for every single problem, right? If you do the whole table, yeah, but what if they ask me for I-27 in a loan of 30 years? Are you going to draw the whole table to get down to 27, I-27, which will be lowercase I times OLB26? You don't want to have to do that, right? So how do I find OLB3? I'm standing here at time 3. 3 payments have been made. What do I owe at time 3? How many payments are left, guys? 22. So can I say this? OLB3 is equal to the payment itself, which is 7822.67, times A angle 22I. Can I do that? Okay, let's clean it up. 7822.67 times 1 minus V to the 22 over 0.06. This turns out to be 94197.32. Then I'm going to say I4 is equal to I, which is 0.06, times that amount, 94197.32. And that turns out to be 5,651.84. And therefore, P4, the principal paid in the fourth year, is equal to the total payment Q minus I4. So Q is equal to 7822.67 minus 5651.84. So P4 is 2170.83. Let's say I didn't want to do all this, right? Is there a shorter way to find P of 4 and I of 4? What formula? I could use the formula, yes. Isn't there a simpler way? If I know the first, the principal paid in the first payment, if I know P1, can I just say P1 times 1 plus I times 1 plus I times 1 plus I, and I would be done. So alternate this time you wouldn't find I first, you would find P first. So what I'm saying is P4 is equal to P1 times 1 plus I to the third power. And I have already found my P1 is 1822.67 times 1.06 to the third power gives me 2170.83. Once I have found P4, I can find I4 by saying Q minus P4 equals I4. And again, I get 5651.84. Quicker. If you've already done the work for P1, just grow it by 1 plus I to the whatever power to get to the fourth year. Are you following me? What's your question? What's on the next page? Part E. What percent of the fourth payment was interest? So I4 over Q. I4 had turned out to be 5651.84. 5651.84. And Q was constant, 7822.67. So 72.25% was interest. So even in the fourth year, you're wasting 72% of your payment is only paying interest, and the rest is paying off principal. Scary, isn't it? Imagine you're paying $7,000, this is annual, right? $7,800 a year, of which only the difference between these two is principal. And everything else is just the cost of having this loan. What is the interest in the last payment and what is the principal in the last payment? So, of course, you can do I-25 equals I times OLB-24. You could do that, where OLB-24 is equal to what? Can you help me find OLB-24? A angle 1, because there's only one payment left, right? So can't you just say, let me take that payment, 7822.67, and take its present value, which is V multiplied by V. So 1 over 1 plus I. I is still 0.06. Couldn't I do that? So I get 7379.88. Therefore, I-25 is equal to 0.06 times 7379.88. And I get 442.79. That's one way. And of course, P25 is just Q minus I-25. And that turns out to be 7379.88. I could do that, or how else could I have found this pair of P25 and I-25? What's the other trick? Or P25 is equal to P1 times 1 plus I to the 24th power. And then I-25 is Q minus P25. That's your other alternative. So you don't have to bother with OLB-24 if you do that, right? Are you with me? Next one. What fraction of the last payment was interest? So we got 442.79 divided by Q, 7822.67. That gives me 5.66% was interest. So by the time you reach the end of the loan, a lot lower percent of that payment is interest. That's what this is trying to show you. Next one. Do you have any question on what we've done? Is it that ridiculously simple, or are you so lost? Which will it be? Melissa, can you talk to me?
I mean, not bad.
No?
I think the true test will be when we're doing the principal test, when we're doing it in class, if things add up. At least to me. I can't speak for everyone.
Okay. Can you give me a summary of the two formulas, or two or three most important formulas so far? Uh-huh.
Well.
No well. Well means stalling. Okay. What have you learned so far? What do you understand so far? Help her, somebody. Yes, L equals QA angle NI, right? And then, what else do you know?
We know that P...
So what do you use this for? What? To find what? Okay, find the constant payment, assuming that the payments are constant, right? Find the constant payment, Q. Okay, then what? What else do you know? Everybody's hiding. Somebody tell me what you know. Yeah.
The second interest payment is equal to the interest rate times the short-term loan balance.
Okay, so may I write this? I at time t is equal to lowercase I times the outstanding loan balance at t minus 1, right? That'll help us a lot. Okay. We also know that P of t, the principal paid at time t, is equal to the total payment minus the interest, because this is an amortization schedule, right? It's amortized. That means you're trying to kill off the loan, but you are obliged to pay the interest first in every payment. They will subtract the interest. The rest will go to principal. Follow me? Okay, what else do you know? Anything else? Yeah, that's the most important one. It'll get you out of a lot of jams. P of t, that's the principal paid at time t, is equal to the principal paid at time 1 times 1 plus I to the what power? Right, t minus 1. So once you know the principal paid in the first payment, you just have to multiply by 1 plus I to the appropriate power, and that'll get you the principal immediately, right? Okay, and then there's one more with knowing that the coefficient of the principal paid plus the time always adds up to n plus 1. So how do we write that? P of t is equal to q v to the n plus 1 minus t. Once you know this, you know that I of t is equal to q minus qv to the n plus 1 minus t. Are you with me? So these will get you through pretty much every problem, as long as the payment is constant at q. If the payment starts growing, this mess goes out the window, okay? And you have to do it on a case-by-case basis. Okay. Yes, ma'am?
Can you spell over one more time how to find
OLB t minus 1. Sure. So you're here at time t minus 1, and you want to know how many payments are left, right? So if you're standing at t minus 1 and there are n payments, there are n minus t minus 1 payments left. I'm so sorry. How's that? So if you're standing at time t minus 1, you have n minus that many payments left. So OLB t minus 1 is equal to q a angle n minus t minus 1. Finished. Right? So if n is 10 and t minus 1 is 6, you're saying that you have 4 payments left. So it's just q a angle 4. And then you plug in your a angle 4 formula and you're done. Follow me. So let me just suppose t minus 1 is equal to 6. Find OLB t minus 1. Okay, let's continue with our business. A $15,000 amortized loan is repaid by monthly payments at the end of each month for 8 years. The nominal rate of interest convertible quarterly is 8% a year. What is the monthly payment? Okay, now they're messing with you, right? They're giving you the quarterly rate and they're telling you that payments are monthly. You have 3 options here. What are your 3 options? Let's take a nice new page where we can do this 3 different ways, because this will review your entire chapter 4. Okay. Let me draw a timeline. And I want to do this part A 3 different ways. This is going on for 8 years. 8 years. And the payments are monthly. And so there would be 96 months. First way to do this problem is to find the monthly rate, find I monthly, and then say 15,000, which is the amount of the loan, is equal to Q A angle 96 at I monthly. Agree? That's the easiest way, right? That's what we fall back upon all the time. So what is I monthly? Can you help me? Right now, what did they tell me? I4, nominal interest rate convertible quarterly, is 0.08. Therefore, I4 over 4 is equal to 0.02. That's the quarterly rate. So I have to change it. 1 plus I12 over 12 to the 12 equals 1 plus I4 over 4 to the 4, so that's 1.02 to the 4. So when I solve this, I get I12 over 12, otherwise known as I monthly, is equal to 0.0066227096. So once I have the monthly rate, I just go do this mess, right? Let's do it. So 15,000 divided by A angle 96, I12 is equal to Q, I112 is equal to Q. So 15,000 over 1 minus V to the 96 over I112. And that gives me 211.65. So this was nice and clean, right? Easy to do. The second way to do this problem is to stay with the annual rate. What is the annual rate? It's 1 plus I equals 1 plus I4 over 4 to the 4, which is 0.082432216. And you could use this. Some annual amount times A angle 8. This is happening for 8 years. at the annual rate, 0.08243216, and payments are being made 12 times a year, right? Payments more frequent than interest is credited. So that's equal to A times 1 minus v to the 8 over I12, which is equal to A times 5.906025118, and that's equal to 15,000. Set that equal to 15,000. And solve. You get A equals 2539.78. That's the annual amount. Annual payment. I don't want the annual payment, I want the monthly payment. So A monthly is equal to 2539.78 divided by 12, which will also give you 211.65. It's more trouble than it's worth, right? A third way to do part A is to understand that there are 32 quarters in 8 years, and payments are 3 times per quarter because the payments are monthly and there are 3 months in every quarter. So how about 15,000 equals quarterly payment times A angle 32 at 0.02, because the quarterly rate is 0.02, and there are 3 payments per quarter. So that would equal some quarterly payment times 1 minus v to the 32 over I3, where this mess right here turns out to be 23.62410 times quarterly payment equals 15,000. And somewhere here I would have to find I3 because I don't have I3. So 1 plus I3 over 3 to the 3 equals 1.02. And solve. That's how I got I3 is equal to 0.019868128.7. So you have to do that before you can finish this thing up and find 23.62. And so the quarterly payment is equal to 23.62410 on the bottom and 15,000 on the top. And I get 634.944. And then the monthly payment is equal to 634.944 divided by 3, because there are 3 months in every quarter, and that's equal to 211.65. Again, it's more trouble than it's worth. However, if you try to do this yourself, it will review all your chapter 4 for you. Follow what I mean? So in any case, the monthly payment is 211.65. The simplest way to do it is the first way. And let's continue from there. So what is the monthly payment? I'm going to say, see next page, page 5A. And I'll call this 5A. So we got Q equals 211.65. And now we can do some sensible stuff. What is the OLB at the end of the 4th year after the payment has just been made? So it's asking me for OLB 48. 48 months. So this is the payment, 211.65, A angle remaining payments. So if I'm standing at time 48, how many payments are remaining if there are 96 payments in all? Another 48 are remaining, right? So A angle 48 at the monthly rate. And we found the monthly rate on the previous page. It's right here, 0.006622, that one. 0.0066227096. And so that's 211.65 times 1 minus v to the 48 over I. And that gives me 8678.39. OLB 48. Next one says compute the interest in the 49th payment. Well, we know that I-49 is equal to lowercase I times OLB 48. So that's 0.0066227096 times OLB 48, that one I just found, 8678.39, giving me 57.47. And therefore P49 is the difference of Q minus I-49 is equal to 211.65 minus 57.47, giving me 154.18. Any questions there? Let's continue. That's page 5. Page 6 is a new problem. Let's do it. A $50,000 amortized loan is to be repaid by annual payments at the end of the year for 10 years. Timeline, 10 years. Loan is $50,000. Each payment, however, is 100 higher than the payment before. Interest rate is 4%. So let's call the first payment P. Next payment is P plus 100. Third payment is P plus 200. Last payment is P plus 900. What is the first payment is the question. In other words, find P, right? What kind of annuity?
Arithmetic.
Yeah, arithmetic. Can you give me the present value of an arithmetic annuity? P, yes, I, P, Q, A, angle, N, I, which is what? What's the formula? P, A, angle, N, I, plus beautiful. Okay, let's go. Let's set up the formula. 50,000 is the present value of I, P, Q, A, angle 10 at 0.04, which is equal to, what's P and what's Q? P is P. I'm looking for P, right? And what's Q? 100, right. So plug in P, A, angle 10, 0.04, plus 100 over 0.04, A, angle 10, 0.04, minus 10, V to the 10. So 50,000 is equal to 8.11085779 times P plus 2,500 times 1.35525. And when I solve for P, I get 5746.82. Basically, everything else is a number. I'm just looking for this P, and I have found it. So the first payment is 5746.82, and the payments increase by 100. Okay, So let me just write here where A angle 10.04 had turned out to be 8.11089577.9. So this is my first payment. What is the last payment? Last payment is just P plus 900 is equal to 5746.82 plus 900, 6646.82. What is OLB 8? So you're standing here at time 8. 8th payment has already been made. I want to know what is OLB 8. How many payments are left, guys? 2 payments left. What are the 2 payments that are left? Right. P plus 800 is the 9th payment. And I want to bring that back 1 year like this. And then P plus 900 is the last payment, and I want to bring that back 2 years. So P plus 800, that's 9th payment. Bring it back 2 years, 1 year, V to the 1, plus P plus 900 is the last payment, bring it back 2 years, V2. So instead of trying to create an arithmetic annuity with the first payment being this one and the next payment being 100 more, it's not worth my time, right? To find the present value of an arithmetic annuity with 2 payments, which is what I would do if I had 20 payments left here. Are you listening to me? If I was standing at time 8 and if I had 20 payments left ahead of me, I wouldn't do this piecemeal like I was doing here. I would write an arithmetic annuity with the first payment being here and the increment being 100. But right now I only have 2 payments, so it's not worth my time to do that. I will just take each payment and discount the payments, which is what I'm doing here. So P plus 800 is 6546.82, and I want to divide that by 1.04. That's 1 plus I, plus the next payment is 6646.82, and I will discount that 1.04 second power. When I clean this up, I get 12440.38. Part D, find the principal and interest paid in the 5th payment. My question to you is, can I take the first payment and grow it by 1 plus I to the 4th power or something like that? Or 3rd power, whatever, some power? No? Why not? Yeah, the Q's are not constant. So cannot use P5 is equal to P1 times 1 plus I to the 4th, since payments are not constant. Okay, so then how shall we do? I want P5 and I5. What shall I do? Matthew, can I pick on you? Try. I5. I5 equals what? Lowercase I times OLB4, right?
Yes.
How should I find OLB4? I'm standing here at time 4. The time 4 payment has already been made. I have a payment at 5, 6, 7, 8, 9, and 10. Or you can look backwards. I can look prospective and see it's a pain in the neck because I've got a payment at 5, 6, 7, 8, 9, and 10. I would have to do some arithmetic annuity with that. Or I can look backwards Retrospective, you want to try? Matthew, you want to try, or shall I leave you alone? Leave you alone? Okay. OLB4, retrospective. Okay. So how do we do retrospective? Take the loan amount, L, grow it to the fourth, 1 plus 0.04 to the fourth power, 1 plus I, sorry, thank you, 1 plus I to the fourth, minus the accumulated value of all payments already made, right? Okay, so my first payment was 5746.82. That payment was made at time 1. I better grow that by 3 years. This is this payment. I have to grow that by 3 years. So 1.04 to the third power plus the next payment was $100 more, 5846.82. I better grow that by 2 years. Plus the next payment was $100 more, 5946.82. Grow that by 1 year, 1.04 to the 1 power, plus 6046.82, and I don't have to grow that one at all. So I did retrospective because I found it simpler. So 58492.93 is this mess, minus the accumulated value of all the payments already made is 25019.82. So I get 33473.11. That is OLB4. So to find I5, I will take 4% of what I just found, 33473.11. And that turns out to be 1338.92. And therefore P5 is equal to the whole payment, which is the first payment, 5746.82 plus 400. This is P1 plus 400 minus I5. So 6146.82 minus 1338.92 gives me 4807.90.